Section 5.7, factoring. So we have introduced several methods before. Now we are dealing with some new formulas. One is that if you have a2 plus 2ab plus b to power of 2, it's a plus b to power of 2. And if there is a negative between, then you have a negative in the parentheses. So if you have the perfect square of two numbers or variables, and the middle term is twice of multiplication of these two, then this is the formula. We want to factor this and using this formula. So the first and the last number of variable must be in the perfect square. And you should have twice of multiplication of these two. So in that case, it's v plus 2 to power of 2. So you understand that, in previous sections, when we ask you to do the factoring for this, you could also use that rule that you need to find two numbers that when you multiply is 4, and when you add these two numbers together also is 4. And those numbers are 2 and 2, positive 2 and positive 2. So we have v plus 2, v plus 2, see? Which is, when you take a parenthesis and multiply by itself, you could write it as v plus 2 quantity squared. So for these problems, there is also another way of doing it. And since they all are positive, that's why we use the top formula. If the middle term is a negative, then you need to use this one. Like problem like this, we want to factor 16x2 plus 24x plus 9. Again, in order to use the formula, the first term and the last term must be in perfect square. See? So in that case, you have 4x plus 3 to power of 2. And according to the formula, what you have is if you multiply these two, 3 times 4x is 12, and multiplied by 2 is 24x. Because the middle term is 2ab, means the middle term has to be 2, and then multiplication of these two, 4x and 3. See, if you have all the conditions, if you meet all the requirements, then you could factor it like that here. Like these problems here. See, before I think of using any method first, you should always apply method number 1. And then if method number 1 does not apply or doesn't work, then you go through the rest. Method number 1 is first you need to look and see if there is any number of variables in commons. 25, 40, and 16, they don't have any number in common. However, they all have x2. So I have to factor x2 out first. Now, within the parentheses, I see the first and the last number and variables are in perfect square. See? Okay? Because 4 squared is 16, and this 125y to the power of 2 is that. And the middle term is twice of multiplication of this, so it's 2 times 4 times 5y, which is 40y. So it met all the requirements. So in that case, then you take these two, raise it to power of 2, and then you carry that x2. See? Now, then we go to the second formula, which is difference of two perfect square, which is conjugate or multiplication of sum and difference of these two. Example, I have b squared minus 36. None of the method work for this. First of all, you have only two terms. Most of the formula we use were not applied for two terms. Are they both in perfect square? Yes. So you open two parentheses. Now remember what you do here is, so basically this formula, look, if I hide the power, see that? That gives you the first parenthesis. So if I hide the power, what do you see? B minus 6, right? You put that here, and the other one is the same with the opposite side. (81) C2 minus 121. We want to factor this. 81 is 9 to power of 2, and 121 is 11 to power of 2. And you could find it, you know, if you keep dividing by 2, 3, 5, and when you reach to 11, when you use your calculator and you divide by 11, then they give you this. Now, there are two terms. They both are in perfect square, right? So you open two parentheses. Now look, what do I do in the first parenthesis? If you hide the power, what do you see? 9c minus 11. So it's 9c minus 11 and 9c plus 11. That's how to factor it. When you have two terms and there is always a negative between. And you could always check, again, you could always check your factoring. Look, when I multiply 9 times 9 is 81C2. 9C times 11 is 99C. Minus 11 is minus 99C, and minus 121. See, these two cancel, so that gives you 81C2 minus 121. That's how you could check yourself to see if it's correct or not. So for all the factoring, you should be able to check. You know, the formula is A2 minus B2. So in these problems, you know, the way the problem is introduced, it kind of different with this one, right? So what if I just put 99 on this side? doesn't matter. Like that, okay? It's the same thing, right? Now, 11 is not in the perfect square. Again, think of the very first method of factoring. 99 and 11, they both have 11 in common. So if I factor that, it would be 9 minus y2. 9 is 3 to power of 2 minus y to power of 2. And look, in the parentheses, I have difference of two perfect square, right? So you open two parentheses. What would be on the first parenthesis if I hide the 2? 3 minus y and 3 plus y. See, in these problems, it's a combination of two methods. First, you use the first method here, which you find the number that is common, and factor that out, and then use the conjugate, which is a minus b times a plus b. And look at this one. This is kind of more complicated than the other ones. I want to factor this. All right, the first three, look, it's like this. The first and the last term is in the perfect square. Okay, so you could write it as x plus 11 to power of 2 minus, you could write also this one as like that. Because x2 to power of 2 is x4. So we used one method of factoring already. Now, this is a conjugate, means this is the one that shows difference of two perfect square. So we open two parentheses, and then I need to hide the 2, right? What we did in the first parenthesis, look. X plus 11 plus x2, and what's in the second one? X plus 11 minus x2. Okay, so some of these problems are not, takes a little bit of time to understand it. That's why we put it in the homework. So we use the first method, and then we use the conjugate, okay? All right, so now that brings us to the very last method of factoring. Here, there are two formulas that we use. You know, we talk about difference of two perfect square, right? Now, what we have, difference of cube. This is a formula. See, with the cube, first of all, you don't have 2ab here, okay? Just ab. And for the cube, we also have formula for positive too. So for positive or negative, you come up with a different formula. So Let's say we want to do this. And remember, you must have two terms, and both terms must be in cubic form. All right, so which formula do we use? This one, difference of 2 cubed. You see that? I'll write a formula here so you could actually see it again. All right. So here in the formula, to find the first parenthesis, if I hide a 3, that gives you the first parenthesis. You see that? So if I hide a 3 here, my first parenthesis is what? W minus 5. So your A here is W and your B is 5, right? So what do you have here? A to power of 2, which is W to power of 2. In the middle, you have positive. AB means just multiply these two, which is what? 5W plus B to power of 2. B is 5. 5 to power of 2, which is 25. That's how I factor it. So sometimes, as I say, it's easier to just write a formula under that, and then you could find your A and B. So what is important is find your A and B. A is W, and B is 5. So when you figure this two, you could take it and put it in the formula. First, think of the method number 1. Do they have any number or variable in common? Yes, they both have y3. So let's factor that out. So it's like that, right? And then 64 is 4 to power of 3 minus x to power of 3. How do I find my first parentheses? I hide the 3, 4 minus x. And then what do I have on the second parenthesis? 4 to power of 2 plus 4x plus x2. So you have this. 4 minus x, 16 plus 4x plus x2. Again, all I need to do is find my A and B. A is 4, B is x. When you find these two, take it and substitute it in the formula. So far we have been using this one because the difference is negative, okay? All right, so now, say factor completely. Factor completely means if there is more than one method to use, go ahead and use it till you cannot factor it anymore. All right. $125 is 5 to power of 3. 216, if I keep dividing it, is 6 to power of 3 y3. Okay? What is my first parenthesis? First, you want to make sure everything is in a cube. Okay? See, look. When you hide the 3, that gives you the first drive. So hide the 3 here. What is on your first parenthesis? 5x plus 6y. So your A is 5x and your B is 6y, right? So what is A to power of 2? What is 5x to power of 2? You don't have room here. I'll show it to you here. 5x to power of 2 minus AB means you just multiply these two. Multiply these two, which is minus 5x times 6y plus B2. What is B? 6y. 6y to power of 2 . See, this type of problems, if you don't do it step by step, it's not that easy to come up with the right answers. All right. Not very easy one, huh? Okay. Y plus z to power of 3 plus 5 to power of 3. So what formula is this? A3 plus B3, right? Is that? So what is your A when A plus B when you hide it? You hide the 3. It's the first parenthesis is y plus z plus 5. See? So what is your A? Y plus z. What is your B? That. So what is A to power of 2? So let's write here. A is y plus z to power of 2. What is B2? It's 5 to power of 2. And the middle is negative multiplication of these 2. So it's 5 times y plus z. See, this is a very long problems. Would you like to have a problem like this on your test? I'm kidding. Okay, so you distribute that. Ooh. Call my hand to the entire. Okay, see, that's what you have. So we actually went through all methods of factoring, and this was the last method or the last formula to use.